Today we're going to be using conversion factors. The word factor should give us the indication that we're going to be doing some multiplication. We talked about that earlier this year when we had scale factors. So our objective is to make unit conversions. Now you've done unit conversions in the past and you do them pretty normally. Unit conversions are something like these. Fill in the missing numbers. 1 foot is equal to how many inches? Well, you know these answers intuitively. 1 foot is equal to 12 inches. 1 meter is equal to 100 centimeters. 1 pound is equal to 16 ounces. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. And 1 day, well, how many seconds is that? That's where it requires a little bit more of a conversion factor. In other words, we're going to be multiplying some stuff together to figure out how many seconds are in a minute, how many minutes are in an hour, how many hours are in a day, and we end up with something like 86,400 seconds equaling 1 day. Now we're going to talk in more detail about how we got that final answer, just not for this specific problem. So, unit conversion factor is a fraction whose numerator and denominator are equivalent measures. Some common unit conversion factors are given below. You can also use the reciprocal of these. Take just a moment and see if you can fill this chart in. All right, your chart should look something like this. 1 foot to 12 inches, 1 yard to 3 feet, 1 mile to 5,280 feet, 1 pound to 16 ounces, 1 pint to 2 cups, 1 quart to 2 pints, 1 gallon to 4 quarts. That series of conversions there should have sounded very familiar because you did those several years ago in elementary school. 1 gallon to 4 quarts, 1 hour to 60 minutes, 1 minute to 60 seconds, and 1 meter to 100 centimeters. Now the inverse or reciprocal of these is true as well. Up here in the top left, 1 foot to 12 inches, it's also true that 12 inches is equal to 1 foot. So we could have written that in the reverse order, 12 inches over top of 1 foot. So let's choose a conversion factor for that. We want to choose a conversion factor that introduces the unit we want in the answer and cancels out the original unit so that the one you want is all that's left. Now, if you're taking notes, that would be a good thing to write down. It's not going to make the most amount of sense until you start working with it. So if you need to pause the video to finish writing that down, feel free to do so. So we do that by using our canceling out words. Now, when we talked about proportions, I encouraged you very strongly to use one thing in your proportions first so that you never mess up, and that is words. The same is going to be true when canceling out units. We want to talk about the words first. I don't care about the numbers until we understand the ability to cancel out words. So, the process of canceling out. We're looking for something in the numerator that matches identically to something in the denominator. Here, we notice that feet matches feet. We can cancel those out. That's no different than dividing 2 by 2. If they're the same, 2 divided by 2 leaves us with 1. Well, feet divided by feet gives us 1. So now we can multiply straight across the top, straight across the bottom. We have inches over miles. Let's try another one. I'm going to give you just a second to figure this one out on your own, and then I'll give you the answer. Okay, we notice that there's seconds in the numerator, there's seconds in the denominator. Those two are going to cancel out. So we're left with hours over minutes. Did you get that answer? Now we take that concept and we're going to apply it to converting 8 yards to feet. Now the important thing about doing a conversion is we need a conversion factor that's going to have whatever we're looking for as our final answer in the numerator. So notice that I want to convert to feet. I need a conversion factor that converts between feet and yards and has feet in the numerator. So which conversion will we use? 3 feet over 1 yard or 1 yard over 3 feet? Yeah, we're going to use the 3 feet over 1 yard because, again, I want my final solution that matches the question we're trying to solve for feet. So feet needs to be in the numerator. Additionally, let's think about the canceling out words. We're starting with 8 yards, and we need to cancel out the word yard. The only way that we can cancel out the word yard is to have the word yard in the denominator. So now, we're set up the problem in my multiply. 8 yards over 1 times 3 feet over 1 yard. We should see, hey, my yards will cancel out. And just like we've multiplied fractions for the last several years, we're going to multiply across the top, multiply across the bottom. 8 times 3 feet is 24 feet over 1, which simplifies to 24 feet. Now that wasn't that complicated. We canceled out the yards, it left us with the unit that we were looking for based on the problem. It gets a little bit more complicated when we have longer word problems. We have to think, okay, what's it asking for? A bucket holds 16 quarts. How many gallons of water will fill the bucket? So we're going to use a conversion factor to convert the units. So we start with our 16 quarts over 1, and we need to multiply by a conversion factor. Now, we know 2 things. We know that we want our final answer to be gallons. So in order for my final answer to be in terms of gallons, I'm going to need gallons written in the numerator of my conversion factor. We also know that the only way that I can cancel out the quarts that's currently next to the 16 in the numerator is to have a quarts in the denominator. So here are our 2 options for conversion factors. Which one of those satisfies both of those requirements? It has gallons in the numerator and quarts in the denominator. Yes, the one on the right. The one on the right has gallons in the numerator and quarts in the denominator. And so now we should notice, hey, my quarts will cancel out because I have one of it in the numerator and a matching in the denominator. And we can multiply straight across. 16 times 1 gallon gives us 16 gallons. 1 times 4 gives us 4. Well, this time we notice we have 2 numbers that have common multiple. We can simplify that fraction. 16 divided by 4 simply leaves us with 4 gallons. So let's make a rate of conversion. Similar idea, slightly different application. We want to convert 80 miles per hour to feet per hour. So we're starting with 80 miles per hour. Couple of things that we want to realize. Notice that since the question is asking for feet per hour, where feet is a distance, and hours is an amount of time. Our starting ratio must also be distance over time. That's the only way that we'll multiply by a conversion factor and end up with a solution that's distance over time. So we start with 80 miles per 1 hour. And now we need to ask ourselves, what are we going to multiply by? Well, here's where we need our conversion factors, and you'll have some of these in your agenda. You also have some that you wrote down at the beginning of the notes. We know that 5,280 feet is equivalent to 1 mile. Using what we've just learned about applying conversion factors, the only way to cancel out the miles would be to have miles in the denominator. And since we're looking for feet in the numerator, our 5,280 feet will go above 1 mile. Well, now is where we can start canceling stuff out. So notice I can cancel out my miles and multiply straight across. 80 times 5,280. And 1 hour times 1 simply gives us 1 hour. Now, certainly we're going to do the multiplication there and simplify that. We end up with 422,400 feet per 1 hour. Convert 63,360 feet per hour to miles per hour. So again, we're looking for miles per hour, a distance over a time. We want to set up our initial fraction as a distance over a time. Well, we see feet is distance, hour is time, so we'll have 63,360 feet over 1 hour. And we need to multiply by a conversion factor. We're trying to get miles over hours, so our conversion factor simply needs to change feet to miles. In order to cancel out feet, we need feet in the denominator. And we want our solution to be in miles, so we need miles in the numerator. So our conversion factor would look something like this. 5,280 feet underneath 1 mile. Well, notice I can cancel out my feet, which is going to leave me with 63,360 times 1 mile over 1 hour times 5,280. Well, that will simplify to 63,360 miles per 5,280 hours. Well, that's definitely a good ratio of miles to hour, but it's not miles per hour. Notice the wording, per hour, indicates per 1 hour. And so now we're simply looking for a unit rate, which is a concept we covered way back in Unit 3 when we did our rates, ratios, and proportions unit. And hopefully you remember that you find a unit rate by dividing your numerator by your denominator so that you get a solution that is one of your denominators per whatever quantity of your numerator. So we divide 63,360 miles by 5,280 hours, and we end up with 12 miles per 1 hour. Now this answer you're going to go ahead and leave in this form. I don't want you guys transferring this into MPH yet, because what ends up happening as you write out MPH is some of you lose the context of what MPH really means or represents. So I want you to leave it in a fraction form so that you still see it as a ratio. Now you try. Now's a good time to pause the video, work out these two problems, and then come back and check your answer. Now, if you converted 32 feet per second to inches per second, you should have had a solution that looks something like this. 32 feet over 1 second times 12 inches over 1 foot. Now, you'll recognize that the feet will cancel out, which leaves us 32 times 12 inches over 1 second times 1, which simplifies to 384 feet per 1 second. The craft store charge is $1.75 per foot for lace. How much per yard is this? So we have our dollars over feet, which is our price over distance. And we want our solution to be price over distance, dollars over yards. So we're going to start off with our initial ratio, 1.75 over 1 foot. We're going to multiply that by the conversion factor. We're trying to cancel out feet. So notice this time, I have feet in the numerator in the conversion factor so that it will cancel out the 1 foot from the original fraction's denominator. This will leave us with 1.75 times 3 over 1 times 1 yard, which then leaves us with $5.25 per 1 yard. The average American eats 23 pounds of pizza per year. Find the number of ounces the average American eats per year. So we want our solution to be the number of ounces per year, so the weight of pizza per 1 year, the time. So we need our initial fraction to start off as weight over time. So notice that we started out with our weight of 23 pounds over 1 year, and we're going to multiply that by the conversion factor. We're trying to change pounds to ounces, so I need a conversion factor that goes from pounds to ounces, and I need the pounds to be in the denominator so that it will cancel out the pounds from our original fraction. That then leaves us with 23 times 16 ounces over 1 year is equal to 368 ounces per year. The car traveled 60 miles on the road in 2 hours. How many feet per second was the car traveling? I'm going to give you a big hint, just like I've been saying before. Set up the words first. How many feet per second? Well, we want distance over time. So my initial fraction should start out with distance over time. Well, in order to change from miles per hour to feet, we need a conversion factor that changes from miles to feet. So we can already see here that if I multiply by feet over miles, the 2 miles units will cancel out. But that would leave me with feet over hours. And the question didn't ask for feet over hours, it asked for feet per second. So yes, we are going to end up with yet another conversion factor. So our first conversion factor changed the distance. Our second conversion factor is going to change the time. So now we need to change from hours to seconds. I have hours in the denominator currently. In order to cancel out the hours, I need a conversion factor that has hours in the numerator. So notice we have hours over seconds. Now that I've set up all of the words, we can go back and fill in numbers. So we have 60 miles per 2 hours. We're going to multiply that by 5,280 feet per 1 mile. That will cancel out our miles. And then we want to figure out the conversion factor from hours to seconds. Well, 60 seconds over 1 minute times 60 minutes over 1 hour means that there are 3,600 seconds in 1 hour. So our conversion, 1 hour over 3,630 seconds. And we should notice that 1 hour here, the hour is going to cancel out this hour back here in our original fraction. Well, now we can cancel out the units, which means we're going to end up with feet per second, and we multiply the numeric values straight across. 60 times 5,280 times 1 over 2 times 1 times 3,600. Which simplifies out to 44 feet per 1 second.